Hello, kulandireni kuphunziro lathu lero pamene tikufuna kumalizitsa topic imene tikhala tikupanga. Muli ndine Siselo Chuma tikhalire limodzi. Phunziro limene tikufuna kumalizitsa ndi exponential and logarithmic equations. Pa topic imeneyi tatengapo nthawi ndithu tikhulupirira amene sitikudziwa kuti tikuchokera kuti ndibwino tikaone ma videos athu amene takhala tikupanga mbuyo. Pa topic imeneyi tinaona definitions, tinatanthauzira, tinapanga express ma numbers, then tinaona zitsanzo, tinaona zitsanzo, then tinasolve exponential equations, then we had an home exercise, this one, I hope tinapanga. Then tinaona tinamba kuona logarithmic equations. Then tinatsamalizitsa kuona ma rules ya logarithms. Tinaona multiplication rule, tinaona division rule, tinaona powers, tinaona base and number mazofanana, then tinaona zitsanzo. Then tinaona the log of 1, rule number 5 and 0. Log of any base, but of 1 is 0, so it's 0. And we had shown that. Lero tufuna timalizitse poona amene tingasolvere logarithmic equations. Tikakambaza an equation imene ili ndi ma variables in the exponents imene tinayitanthauzira kuti the exponential equation. Now, in contrast to that, an equation that involves the logarithm of an expression containing a variable is referred to as a logarithmic equation. Now, the purpose of solving a logarithmic equation basically is to find the value of a known variable. Yeah, those are simple definitions. Now, let's look at types of logarithmic equations. Equations containing logarithms on one side of the equation, that's type number 1. The equation you can thus say A is equal to, let's say, 12. So, according to this one, it means that the logarithm itakukhala mbali imodzi A. Okay? Kapena itakukhala mbali inayo. Okay? So, equations containing logarithms on one side of the equation is what we call, that's the first equation. And equation number 2, the many logarithms on both sides, which means saying, okay, the logarithm body and outside body. Okay, let me put P there. Okay, leave it be. Okay, you can have logarithms this side and logarithms that side. So, for the time being, it's as many as we take logarithm mitundu iwiri, tundu oyamba amakhala mbali imodzi, tundu achiwiri amakhala mbali zonse. Now, how do we solve equations with logarithms on one side? Okay, so that's an example for a logarithm of one side, saying log base b, log of m, base b should be equal to n. Now, on how to solve this one, first of all, you have to simplify the logarithmic equations by applying appropriate laws, okay, of logarithms. In this case, in the modes, koma matokhala awiri atatu, so you look at those laws, multiplication rules, power laws, division law. You look at all those laws, then you simplify your expression, your equation. After simplifying it, that's the first point. You have to simplify. You have to rewrite the equation into an exponential form. Okay? So how do we do that? We show that already. Say, in this case, for you to transform that into an exponential form, you say m will be equal to base to the power n. So you take that one into that form. Now, after doing that, you simplify this one. After simplify, you verify your answer by substituting it back in the logarithmic equation to see if it has given you what you wanted. Yeah. So basically, that's the procedure. Mene umatsatira kuti muntu usolve logarithm equation imene ndi imbali modes when logarithms are on one side. First of all, you simplify your given problem. After you simplify it, you rewrite that problem into an exponential form. Now, after doing that, you also simplify that exponential form and solve for the unknown or variable. After that, you will verify if you have done the Zorongo solve. Okay, so let's look at an example. Examples, not just an example. We have example 1, where we are saying log of 5x plus 7 of base 2 is equal to 5. Okay. In this case, we want to find x. That's unknown. In the second example, that one as well, and that one as well. Okay, so we have to do all that. So TS over, my examples are following those following these steps. Okay. Okay, so let's look at example 1. Solve log, that's log base 2 log of 5x plus 7 base 2 is equal to 5. Okay, so if we have to solve this one, first of all, tunanena kuti we have to simplify this one, but this one is already it's already in a simplified form. So we go to step number 2, where we are going to change that one into an exponential form. So for us to change this one to exponential form, we'll have 5x plus 7 will be equal to 2 to the power 5. Okay, and this one will be equal to 5x plus 7 is equal to 2 to the power 5, that's 32. Then you have 5x plus, you take 7 there to the other side, you have 32 minus 7, you have 5x will be equal to 25. Then our x will divide both sides by 5. Let's not jump this step. Then you have 5x divided by 5 is equal to 25 divided by 5. Then your x will be equal to 5, we'll go 5 there, 1, 5 there, 5. So that's your value of x. X is equal to 5. Good. That's example 1. Let's look at example 2. example 2, they're saying solve for x, this one. Solve for x in log 5x minus 11 is equal to 2. Okay, so let's solve that. So that's example 2. Let's say log 5x minus 11 is equal to 2. Let's verify it. Yeah, log 5x minus 11 is equal to 2. Yeah, pali chinthu chimodzi chimene mukayenera kudziwa apa base sikutionetsa. Okay, ikakhala silent chonchi base kuti sakutionetsa, umadziwa kuti umayenera kudziwa kuti that's a base 10. Pamene base sanationetse, just bear in mind kuti imene ndi base 10. Okay, so solving this one, well, it's already in a simplified form. We are just going to go to the second step, whereby we are going to change this one into an exponential equation. So for us to change this one into an exponential equation, it will be 5x minus 11 is equal to base to the power 2. So it will be 5x minus 11 is equal to 10 to the power 2, that's 100. So 5x will be equal to 11, it will be 100 plus 11, which means 5x will be equal to 111. Okay, then x will be equal to, if you divide both sides by 5, okay, so x will be equal to 111 over 5. Okay, that's that. Okay, let's look at the third example. So the example that's saying in this one ionetsa log 2x plus 1 base 10 is equal to 3. Okay, so let's look at that. Example 3. Here, given on log base 10 is 2x plus 1. This one should be equal to 3. So, already in a simplified form, we are just going to change this one to an exponential equation. So, we have 2x plus 1 is equal to 10 to the power 3, which means 2x will be equal to plus 1 is equal to 1 0 0 0. Okay, so 2x will be equal to 1 0 0 0 minus 1 when 1 goes to the other side. So you have 2x is equal to 999. Sorry, divide both sides by 2. This one goes, so your x will be equal to excuse 9 2. Okay, basically that's that. And let's look at those other examples. This one now. And this one, the saying solve the logarithmic equation log x plus 1 plus 2 minus log x minus 4 plus 2 is equal to 3. Okay, so let's look at that. Okay, sorry. Yeah, so this example, this should be example 4, where we are saying log x plus 1 plus 2 minus log x minus 4, so base 2 should be equal to 3. Okay, so in this one, there is any form whereby we have to simplify it. For us to simplify it, we are going to, this one they are subtracting, so we are going to use a division rule. So if we have to apply division rule, it will be x plus 1. Please go and check those rules. Is equal to 3. So this one is a simplified one. So I'm going to write it in a form of an exponential equation. So we have x plus 1, x minus 4 should be equal to the base to the power 3. Okay, so this one will be equal to x plus 1 over x minus 4 is equal to, that's 8. Okay, so simplify this one. You have x plus 1. We have to take this one to that side, so we cross multiply here in base over 1, cross multiplication. So you're going to have this one, x plus 1, that one will be 8, x minus 4. Okay, then this one will be equal to x plus 1 is equal to, if we expand that one, it will be 8x minus 8 times 4, that's 32. Then like terms together, you have 8x plus x will be equal to minus 32 minus 1. 1 a bit of work minus no. Just a moment. Yeah, like that. Okay. All right, let's do it again. Like terms together, 32 abelok. So it will be 1 plus 32, b plus 8x, x abelok. So it will be 8x minus x. So it will be 33 is equal to 8x, 8x minus x, that's 7x. Okay, so 7x, so our x will be equal to 33 divided by 7. Okay, that's that. Let's look at the final example, this one, where they're saying solve for x if log for x if log x base 4 plus log x minus 12 base 4 is equal to 3. So let's solve that one. Okay, so this is example 5. Okay, so here we have log x base 4 plus log x minus 12 plus 4 should be equal to 3. Okay, so let's simplify this one as well. This one we're going to use multiplication rule. So it will be log 4x times x minus 12, okay, should be equal to 3. Simplify this one into an exponential form. You're going to have x minus 12 is equal to 4 to the power 3. Okay, so expand this one, we'll have x squared minus 12x is equal to 64. Okay. If you look at this one, this is a quadratic equation. X squared minus 12x. Take this one too. You have 64. It's equal to 0. So, let's get this far. You solve for x by either formula, using factors, completing a square. For you to find the value of x, you just have to solve this quadratic equation. We are not going to do it here. We had a video. We had videos. Then my video how to solve quadratic equations. So you can reach at that point and continue solve it. I'll give you as an assignment to find the value of x. Yeah, so I think come as an example also, solving quadratic equations on one side where we have logarithm equations where we have logarithms on one side. Now let's look at how to solve equations with logarithms on both sides of the equations. The equations with logarithms on both sides of the equation of the equal sign, you take log, like that one, log m and log n, which is the same as log m is equal to n. Okay. The procedure of solving with equations with logarithms on both sides of the equal sign, procedure number one is whereby if the logarithms have a common base, simplify the problem and then rewrite it without logarithms. Okay, you simplify it. After you simplify it, you just rewrite without logarithms. Mene atu fotokozerera hapo. Nina kuti log m is equal to log n is the same as to say m is equal to n. Okay, in other words, adding antilog on both sides. Okay, taking an antilog is the same as dividing by log, but it's just an antilog. You take an antilog on both sides, so you remain with n. Okay, so it's just that. Okay, so 2 steps, you simplify them. After simplifying them, you also simplify, then you solve for variables. This one is a little more simple. Let's look at these examples. Okay. Yeah, so example number 1, saying log 2x minus 4 base 6 plus log 4 base 6 is equal to log 40 base 6. Okay. You see logs are on both sides. Okay, so the first thing we have to do, let's look at this example under this one. Let's say this is example 1. So the saying log 2x minus 4 this one is base 6. Remember, the logs have to be of the same base. Oh, base 6 should be equal to log 6, like 40 base 6. Okay, the first thing is to simplify. In this case, we'll simplify on the left hand side. You have log base 6. In this case, it's multiplication rule. So it's 2x minus 4 multiplied by, just multiplied by 4. This one will be equal to log 40 base 6. So if we further simplify this one, we'll have log 6. Expand that one, you have 8x minus, I think 16 should be equal to log 640. Alright, so we take antilog both sides, then it's the same as to say 8x minus 16 is equal to 40. All right. So 8x is equal to 40 plus 16. So 8x will be equal to 56. So after dividing both sides by 8, let us show it. And that's 7, which means your x will be equal to 7. Okay. Let's look at the second example. Example 2 on this one. We're saying log should be 7 x minus 2 plus log x plus 3 base 7 should be equal to log and 14. Okay, so simplify this side. You have x, log, in this case x minus 2 x plus 3 base 7. This one should be equal to log 14 base 7. Okay, then we're going to drop the logs. We'll have x minus 2 x plus 3 is equal to 14. So expand this one, you have x squared plus 3x minus 2x is equal to minus 2x, then not plus but minus 6 should be equal to 14. Okay, so you have x squared, 3x minus 2x, that's plus x minus 6 is equal to 14, which means x squared plus x minus 6 minus 14 is equal to 0, which means x, okay, let's do it like that. You have x squared plus x minus 20 is equal to 0. Okay, this one as well is a quadratic equation. You solve it using quadratic methods to find the value of x. Then let's look at the last example, this one. Okay, this is the last example. It's example 4. Now let's look at this last example. That's example 4. Okay, we have jumped one. With that one, you can do it the same as what we have done. Just simplify, then drop the logs. Let's look at the last example. This last example is saying log 30x minus 10, let's specify this one minus 2 is equal to log 5x plus 6, sorry, Okay. Yeah, if you look at these ones, this is just a number. It's not a log. This. Okay, so we are going to put like terms together. So that log will come to the left hand side. Log base 5. Remember this is 30x, sorry. 30x minus 10 minus log x plus 6 base 5 should be equal to 2 capital go, it will be plus 2. So we're simplifying the left hand side to have log base 5 30x minus 10. Now division rule, because we're subtracting, x plus 6 should be equal to 2. Then we are changing this into an exponential, form. 30x minus 10 over x plus 6 should be equal to 5 the power 2. Okay. Then simplifying this one, you have 30x minus 10 over, let's just go to the other side. Yeah, you have 30x minus 10 over x plus 6. They should be equal to 25. 5 to the power 2. Okay, so you have 30x cross multiplication will be equal to 25 in the bracket x plus 6. Okay, then you have 30x minus 10. Expanding that side, you have 25x plus just a moment. Yeah, that's plus 25 times 6. 25 times 6. That will give us 150. That's 150. Then you have 30x, like terms together, minus 25x, equal to 150. We are capital equal to b plus 10. Then you have 5x will be equal to 160. That one, 30x minus 25x, that's 5x. So divide both sides by so we are going to divide both sides by 5. Okay, so that one goes that into 160. 160 divided by 5. I think that's, is it 32? Yeah, 32. So x will be equal to 32. Yeah, so reaching that far, tukitamaliza lesson yathu ya lero, natenda kukonserani kuti timalizitse china chilichonse chimene chinatsala pa on this topic, kuti next video tizabwere pa topic ina. Okay, so in the exponential and logarithmic equations tamaliza chilichonse. So kwambiri mukhale ndi sabata yopambana.